Most traditional manufacturing processes require custom tooling to create end-use parts. However, tooling comes with high upfront costs and weeks or months-long lead times from service providers, slowing down product development and extending the time it takes to get a product to market. Incorporating in-house rapid tooling, such as 3D printed molds, patterns, and dies into the product development process, empowers businesses to validate the design and material choice with functional prototypes before transitioning to mass production, and provides an affordable means to produce custom or limited series of end-use parts. In this video, we'll cover the fundamentals of rapid tooling, its applications, and how 3D printing can help you develop tooling to scale low to medium production. How rapid tooling with 3D printing works. Stereolithography, or SLA 3D printing technology, is a great choice for quickly and cost-effectively producing 3D printed rapid tooling. Molds, patterns, or dies produced with SLA 3D printers are accurate and have a smooth surface finish, which will be transferred to the final part with high precision. Formlabs' ecosystem of accessible 3D printers and high-performance materials can be easily integrated into industrial workflows to fabricate strong, smooth, and highly detailed molds and patterns capable of producing hundreds to thousands of parts. Here's an example of a rapid tooling workflow with 3D printing. First, design the tool in CAD. Then, choose the right resin from our expansive materials library and 3D print the part on a Formlabs SLA 3D printer. Next, insert the 3D printed rapid tool in your machine and use it in your normal workflow. Finally, post-process the end part as needed. Rapid tooling applications with 3D printing. 3D printing can be used to support a variety of traditional manufacturing processes to produce plastics, silicone or rubber parts, composites, and even metal parts. Use 3D printed molds for manufacturing processes such as injection molding, overmolding, compression molding, thermoforming, casting, or sheet metal forming. Let's see some examples of how innovative companies have been using Formlabs 3D printers for rapid tooling. Injection molding is one of the most popular manufacturing processes for thermoplastic, silicone, or rubber parts. Due to the excessively high cost of traditional metal tooling, it is also the process that can benefit the most from 3D printed rapid tooling. Shenzhen-based contract manufacturer Multiplus uses 3D printed injection molds with the strong, stiff, and heat-resistant rigid 10K resin on Form 3 SLA 3D printers, shortening lead times for small batches of around 100 injection molded parts from 4 weeks to only 3 days. Additional examples include emergency mask straps by petrochemical company Braskem, and prototype and pre-production parts for the clients of manual injection molding machine manufacturer Hollemaker. Product development firm Glassboard leverages the printing speed of draft resin to quickly produce molds and thermoform polycarbonate prototypes such as helmet shells or packaging. They can achieve complicated mold shapes that would be difficult to manufacture traditionally, including small features and holes for an even better vacuum distribution across the surface. Cosmetics manufacturer Lush used to craft the master molds for their hugely popular products by hand, but recently they turned to 3D printing to create vacuum-forming molds for detailed and textured designs, which allows them to take ideas from concept to reality in under 24 hours and test more than 1,000 designs each year. 3D printed rapid tooling is also ideal for cost-effectively manufacturing custom or customized end-use parts. For example, vacuum forming over 3D printed models is the go-to method for producing clear aligners in orthodontics. High-performance composite materials, such as carbon fiber, can also be molded on 3D printed tools due to the smooth surface finish of SLA printers, which is essential for layup molds. The Formula student team of TU Berlin hand laminates carbon fiber parts on 3D printed molds for racing cars. Printed with tough 1500 resin, the mold is not only strong and supportive during the layup, but also sufficiently flexible to separate the part from the mold after curing, unlocking design possibilities. 3D printed molds can also be employed for molding silicone or rubber parts and overmolding inserts or internal hardware. piece-picking robot manufacturer Right Hand Robotics brought the production of adaptive flexible fingers in-house with 3D printed molds and overmolding. There is an internal wire channel through the core of the fingers that is only made possible with 3D printing technology. Product developers at kitchen appliance manufacturer OXO use 3D printing for prototyping rubbery components, such as gaskets, by compression molding two-part silicone using 3D printed molds. 3D printing also empowers you to create castable patterns in hours, cutting down on manual labor. It allows jewelers to move directly from design to production, while engineers can leverage the speed and flexibility of 3D printing in combination with casting workflows to produce metal parts at a lower cost with greater design freedom and in less time than traditional methods. Casting is also a popular method for producing silicone and plastic parts for medical devices, such as patient-specific pessaries or custom ear molds for hearing aids, noise protection, and custom-fit earphones. SLA 3D printing technology presents some interesting properties for sheet metal forming as well. SLA printers can fabricate tools with excellent registration features for better repeatability. Resins are isotropic and fairly stable under load compared to other 3D printing materials. Combine 3D printing with traditional manufacturing processes and bring your production to the next level with in-house 3D printing, powered by Formlabs.